Okay, good morning, students. So, today let us see the cycloidal curves. So, what is a cycloid? So, it is nothing but when a point on the circumference of the circle is going to move in different positions when it is formed a smooth hand curve. Smooth hand curve for one complete revolution will be a cycloidal curves. So let us see what are the different types of cycloidal curves. So number one, it is cycloid, and number two, this is epicycloid, and number three, hypocycloid. So these are the three cycloidal curves, and another curves are there, that is involute, and fifth one is evolutes. So these are the major cycloidal curves which is there in the engineering graphics and for the design purpose of the engineering curves. So especially these are used in the manufacturing of gears, that is for in the application of automobiles, even though in watches and many other systems which drive maybe the gear mechanism. So right. So now let us see what is the differentiation between a cycloid, epicycloid, hypocycloid, involute, and expect. So today let us see the difference between these three. Okay, what is a cycloid? So that I will try to have my simple definition. So what is cycloid, what is epicycloid, and what is hypocycloid? So as previously I told that the curve formed by a point on the curve, sorry, on the circle for one complete revolution without any slip. So in the sentence form, it is not able to remember you easily. So in the matter of pictorial form, I will try to explain you to remember the definition of a cycloid, epicycloid, and hypocycloid very easily. So here simply, first of all, I'll draw a circle. Okay, this is a circle. Now I'll put a point at the bottom of the circle, and I'll draw a straight line here. Okay, straight line here. Now I'll tell you the definition of a cycloid. Please listen clearly. The curve which is formed by the point on the circumference of the circle is rotating in clockwise direction for one complete revolution without any slip on a plane surface. Now this is the plane surface, this is the circle. Okay, now let me divide this circle into just four parts. Now for one complete revolution, so this is going to travel at a distance of pi d, at a distance of pi d. Pi d is nothing but the circumference of the circle. So for one complete revolution of this circle, the circle point, this is P, is going to travel pi d distance up to the second point, that is P dash. Okay, this is how we are going to define the cycle. So how it is going to travel? So let us take the position. Suppose if I go to the second position, this may be first, and this may be second, and this may be third. So this is 1, this is 2, this is 3, and this one once again P, that is one for P dash. Okay, so once again I will try to define the definition. The point on the circle circumference, rolling on a plane surface, rolling on a plane surface for one complete revolution, for one complete revolution in clockwise direction without any slip. Okay, without any slip. So this may form a cycloidal curve. So the procedure, the steps of the procedure, and I will discuss you in the later. And next, this is what about the plane table. Just you have to remember only one thing. That is the on the point on the circumference. This is first point. Second point, rolling on plane surface, rolling on plane surface. Third point, one complete revolution. Fourth point, without any slip. These 4 points to be remembered very carefully so that you will get the definition. Simple definition, I will read out this point wise. The curve formed by the point on the circumference of the circle rolling on a plane surface for one complete revolution without any slip is the definition of the cycloid. And simply if you define this, remember these 4 points, a cycloidal curve will be formed. And next, in case of epicycloid. So what is an epicycloid? Epicycloid is nothing but when a curve is formed on the another surface of the bigger circle. So this is a bigger circle, and let me take this center point as O, midpoint, and I will draw another line here at any place. So I will take first point, and I will take the center C as the smaller circle, rolling circle center, and simply I will draw another circle here. So now this is the guiding circle, and this one is the rolling circle. Guiding circle and the rolling circle. The same definition, you remember, point on the circumference of the circle. Here, rolling on plane surface, but in case of this one, rolling on another surface of the circle or outside the surface of the another circle. Third point and fourth point is same for one complete revolution without any slip. So here, the second point is changed. So first point is same as above, and second point is just simply change, that is rolling on another surface of circle and outside Same third and fourth point, both are same as above. So here the simple definition of a epicycloid is defined as the point on the circumference of the circle rolling on the another surface of the circle or outside of the another circle for one complete revolution without any slip is nothing but the epicycloid. And what about the hypocycloid? So simply you have to notice that when the rolling circle is rolling on the another surface of the circle, it is epicycloid. And when the rolling circle is inside inside, inside of the circle, inside of the circle, then it is called as hypocycloid. So this is what the little, a small difference. So now I will explain once again three: epicycloid, sorry, cycloid, epicycloid, and hypocycloid. A point on the circumference of the circle rolling on a plane surface for one complete revolution without any slip. This is plane surface. Second, epicycloid. So this is epi and this is hypo. I think it is clear. The point on the circumference of the circle, this is point P. The point on the circumference of the circle, rolling on another surface of the circle is called epicycloid. And the point on the circumference of the circle, rolling inside the circle for one complete revolution without any slip is nothing but the hypocycloid. So this is the three different cycloidal curves which we are going to see now. Okay. So now see here, clearly writing the definition of cycloid. It is defined as the curve formed by the point on the circumference of the rolling circle, rolling on plane surface. Let us take an example as table, ground, etc. for one complete revolution without any slip. So I think you have got a clear idea about what is the definition and what is a cycloid. So now take a circle. So let us assume, take diameter of a circle is 50 mm. 50 mm. Okay. Now I have drawn a circle with the center C as a point. I'll draw a circle with the diameter radius of 25. Then next I'll divide this circle into four equal parts. You know how to make it into four equal parts. Just simply draw a vertical line passing through the center of the point, and next the horizontal perpendicular to the vertical line, horizontal point, you will divide it into four equal parts. Then the bottommost point is located as point P. Now this is the moving point. So now what I will do is, so for construction purpose, these 4 points is not enough to me to have a nice cycloidal curve. So now what I will do is, I may divide into 8 equal parts, 12 equal parts, or maybe 16 equal parts. You can also draw with this, but to get an effective curve, smooth curve, it is not possible with these 4. If you are expertised, then it is possible, but it is not so easy to complete with 4 points. So take 8 or 12 equal parts. So how to divide a circle into 8 equal parts? You know already a method called bisect an angle. So bisect an angle. So take any radius, convenient radius, just you make an arc, with the same radius, this point as a center you make an arc, and this point as a center you make another arc. So you get a point of intersection here. Simply draw the point of intersection to this point from the center of the circle that is going to be divided this particular part into 2 equal parts. Now this is 45 degrees and this is 45 degrees. Simply you need not make another angle bisector. Simply perpendicular to this one, if you draw another line passing through the center of this circle, the circle is going to be divided into 8 equal parts. Okay, now we can see clearly it is 8 equal parts. Okay, so now I'll erase this one. Fine. Now I will name this as 1, 2, 3, 4, 5, 6, 7, and the 8th point is P. So after giving the numbering, in anti-clockwise direction. Why in anti-clockwise direction? You may be noticed in the further explanation. After completing the numbering, you draw the line from P to P dash. You draw a straight line that is parallel to 2 and 6, a straight line. What should be the length of this one? The length of this one should be pi d. Pi d. So what is the value of pi d? So here simply calculate pi into d, that is equal to, let us take 3.14 into 50. So you will get some x value in terms of mm. Okay, so this x value should be placed here, pi d. So whatever it may be, 50 millimeters, 60, 70 or 80, whatever it is. Right. So now P dash is having some distance x. Now, how many equal parts are made in this circle? 8 equal parts. Now, divide P dash, divide this P dash, divide, see here clearly, divide P dash into 8 equal parts. Why 8 equal parts? As I have divided this rolling circle into 8 equal parts, PP dash is the length of the circumference in a straight line. So that is why I am dividing the circle or the circumference length PP dash into 8 equal parts. How to divide 8 equal parts? So simply by line division method you have to make it. So just draw an incline line, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, give the numbering 1, 2, 3, 4, 5, 6, 7 and 8. After giving 8, simply join this last point to the end point. Okay, then next draw the parallel lines from 7, 6, 5, 4, 3, 2, 1. After drawing all these parallel lines to 8 and P dash, 8 and P dash, now it is clear P dash. Name it as 1, 2, 3, 4, 5, 6, 7 and that is P dash. Now I have divided the P dash circumference length into 8 equal divisions with the line division method. Next, now I start rotating this one. When I start moving this circle for one equal part, so this one is going to touch this particular part. And then once again move, this 2 will touch this 2 point on this PP dash line. Once again 3 will touch 3, 4 will touch the 4. So here when 4 touches the ground, this fourth point touches the ground, it is nothing but the circle is rotated or revoluted for one half, that is half revolution. And fifth, sixth, seventh and eighth, it is one complete revolution. Right. So now what is the procedural steps to draw is, draw a line parallel to this one. Okay. Next, parallel line, one more. Then next, from the last point 4, another parallel line. So these lines are construction lines, so that is why I am drawing lightly, so that please visualize it clearly. Then next, after constructing the parallel lines from the respective points on the circumference of the circle parallel to PP dash, now locate the center points. Locate the center points with respect to 1, 2, 3, 4, 5, 6, 7, and 8. So how to locate the center points of respective points? So first of all, you have to identify one point P on the circumference of the circle is at the bottom. Where is its center? Exactly above. That is nothing but this PC is perpendicular to PP dash. Now, such that when one first equal part touches 1 on the PP dash line, where will be the center? The center will always be exactly above 1 1 dash. Nothing but when in this case it is perpendicular, and first case, second case, third case, and so on up to P dash case also, it will be perpendicular. So now draw the perpendicular lines to P dash from each and every respective points up to the center line. So now I will draw a perpendicular lines from each and every division. Okay, so now this one. Now name this one as C1, C2, C3, C4, C5, C6, C7, and C8. What are the C1, C2, C3, C4 up to C8? These are the centers of the rolling circle with respect to the equal parts. When these equal parts are going to meet these equal parts on the rolling circle, rolling plane, right? Now, see clearly with the radius of PC, with the radius of the circle or PC as a radius, PC as a radius, C1 as a center, C1 as a center, make an arc here. Okay, make an arc on 1 1 dash line. This is 1 arc 7 arc, whatever it is. Next, with the same radius, 2 as a center, C2 as a center. Where is the second part line? Second part line is this one, second and sixth line. With C2 as a center, make an arc on the second line. Next, C3 as a center with the same radius, that is the radius of the circle. C3 as a center. Where is the third line? Third line is here. So C3 as a center, you make an arc here. Okay. Next, C4 as a center, it is exactly above, make an arc. Okay. C5 as a center. Now you see, when C1 is there, the point is getting left hand side of this one. Right. This point now move to top. Then next, after the top, when you go to the right hand side, this is C5, then it moves to the right hand side. C5 as a center with the same radius of the circle, you make another arc, C5. Okay, C6 as a center, this is the sixth line. Once again, you make an arc. C7 as a center, another arc. Okay, C8 as a center, you will get an arc here. Okay, now name these points. Name these points as, let us take this is P1. I think it is little bit confusion. Next, this is P2. This point is P2. This one is P3. This point is P4. It should be exactly above this one. And this point is P5. This point is P6. This one is P7. And this one is P dash once again. Okay. Now, draw a smooth hand curve pass from P to P1, P2, P3, P4, P5, P6, P7 and P8. So now this is the cycloidal curve. So this is not as per the scale. So you may get a smooth curve. Okay, right. So now this should be done. So you can see the picture. only the cycloidal curve should be dark and PP dash should be dark. Other than that, all the lines should be thin because all the lines are the construction method so that the line should be very thin and light. Only the circle and the PP dash line and the cycloidal curve should be thick and dark. Okay, then now how to get the tangent and normal. So tangent and normal is, let us take, we have very different conditions are there. So let us go for one of the condition. So any point on the curve, let us take any point on the curve. So now I'll take a point here, a point on the curve. So let us take, I'll take the point as M. I'll take in the point where I have to draw the tangent and normal. So this is the point on the curve. The procedure to draw the tangent and normal is take the radius of the rolling circle, that is R, that is nothing but 25 mm. Okay, keeping M as a center, make an arc on the center line. Make an arc on the center line. Okay, next, after this getting a center mark on the center line, draw a perpendicular line to the PP dash. Draw a perpendicular line to PP dash. After getting this point, just mark it as N. N. So now draw a line from N point to the taken point of the curve M. This is normal. And you know, tangent is perpendicular to the normal and normal is perpendicular to the tangent. So draw a perpendicular line which is passing through the curve is nothing but tangent. So this is how to draw the normal and tangent. Once again I repeat how to make a tangent and normal for a cycloidal curve. First take any point on the curve, take the radius. Okay, just keep the point as a center, make a arc on the center line. Then next, from this point, draw a perpendicular line to the PP dash. Okay, after getting it, name it as N. From this point N to the taken point of the curve, draw a line which is the normal and draw a perpendicular line to this normal. Draw this one and name it as tangent. So this is how to complete a picture. Okay. Suppose in this case of cycloids, now this is a plane surface. Let us take. So in some problems, what they do is the surface of the plane is inclined to 20 degrees or 30 degrees they may give. Suppose if the theta inclination is given as 20 degrees, then what you will do? So now this is a plane line. Suppose if I have given theta degrees as 20, then what you will do is you take this point, okay, and you draw a line with 20 degrees. Okay, then after that, the construction procedure is same. Okay, so like that, whatever the problem is given, just try to understand and give the solution perfectly. And one more thing you have to remember is you have to give all the points and P1, P2, P3 up to P7 or P dash clearly to get the full marks. And pi d is also important. And here dimension line is also important. It should be very thin. Only circle P dash line and the cycloidal curve, tangent and normal should be dark. And other than that, the construction procedure should be very light and thin. Okay.